Hello, and welcome to a conversation on a pretty exciting topic that is support for AI and ML in Snowflake. Let's get right into it. There are so many features and sub features and offerings that Snowflake has in the AI ML space that really, in order to make sense of them, we've got to draw a tree diagram. At a high level, there are two broad categories. One is functionality, which has to do with large language models and AI, and the other that has to do with more traditional end to end machine learning workflows where you build your own custom models. This distinction roughly mirrors the evolution of ML into AI. More recently, we've had a lot of hype around large language models and other AI features, and these assist us in writing Snowflake SQL commands. There's AI powered search, as well as pre trained LLMs that we can interact with. And then, of course, the second bit of functionality is more traditional. This is where we build models to train on our data and use either Python or just SQL. Now, the names for these two broad categories are different as well: Snowflake Cortex and Snowflake ML. Snowflake Cortex is a suite of AI features mostly focused on the use of LLMs or large language models in order to understand unstructured data, answer free form questions, and provide assistance, such as in the form of the Snowflake Copilot. Copilots are, of course, all the rage these days. Every company seems to be coming out with its own Copilot offering. And then there is Snowflake ML, which has custom functionality for building your own models. Now, we are going to work our way through all of this material. However, it'll take us a while to get to Snowflake Cortex. So let's quickly introduce the offerings in Snowflake Cortex just so that they are not unknown to you. Broadly, within Snowflake Cortex, we've got six features or six sets of functionality currently available as of late July, early August 2024. Please note that a lot of this functionality was just launched about a month and a half ago. Now, I find the names of these products and features rather confusing. So, before we get to the names, let's talk about the kinds of technical and business problems that they can help with. The first category helps with summarization, translation, and sentiment analysis with LLMs. The second is effectively a natural language assistant or a copilot to help you as you work with Snowflake. The third is AI powered search within Snowflake. The fourth category allows you to extract text and graphical data from documents. As we move from left to right, notice how the use cases are getting more novel and more unique to Snowflake. In any case, the fifth category involves the use of LLMs that can be fine tuned to work on custom prompts. And the final category is again related to search, but this one is a lot more interesting. This is a way for you to build your own internal search in your Snowflake apps using your own custom data. Now let's introduce the names. The first feature is called Snowflake Cortex LLMs. The second is Snowflake Copilot. This is a fairly straightforward name. The third, which is the AI powered search within Snowflake, is called Universal Search. The feature to extract text from documents is called Document AI. The LLMs that are fine tuned on custom prompts, that's called Cortex fine tuning. And then the more advanced internal search is called Cortex Search. Let's spend a moment talking about each one of these in turn, starting with Snowflake Cortex LLMs. These allow us to access several LLMs which have been built by researchers at companies such as Google, Meta, Reka, Mistral, as well as Snowflake Arctic. This is Snowflake's own enterprise grade LLM. These LLMs are fully hosted and managed by Snowflake, so you don't need to perform any setup, and your data stays within Snowflake when you use these models. Snowflake Copilot is exactly what you would expect. It helps you with natural language requests that you can punch in as you are working with Snowflake, and it can help you write SQL queries, optimize your queries, and generally be your friend philosopher guide as you work with Snowflake. Next up is Universal Search. This is the AI powered internal search. The good bit about it is that it allows you to type in fragments and have typos in your queries, and because it's built on LLMs, it's still pretty forgiving in terms of interpreting your queries. It will search all of the usual places: the Snowflake marketplace, your own data, Snowflake documentation, and the Snowflake community base. It's worth mentioning here that Universal Search is role-based access control aware, so it's only going to give you suggested results based on your level of access. Document AI is an interesting feature. This makes use of the Arctic tilt, that's the proprietary LLM that we discussed earlier, and it's used to extract data from documents. These documents could come in several different types of formats, such as PDF, Word, PowerPoint, and so on. And the information that you extract could be either text heavy or in graphical form, such as logos or handwritten text and signatures. Cortex fine-tuning is a way to customize existing LLMs for your specific task. And the last feature, that's Cortex Search. This makes use of a technology known as Retrieval Augmented Generation, or RAG, in order to provide low latency, high quality fuzzy search over your Snowflake data. We're going to talk about all of these features in more detail, but that's quite a ways away because we are first going to turn our attention to the more traditional Snowflake ML features. So please think of this conversation we've just had as a quick introduction to Snowflake Cortex. Now let's turn to the other branch of our tree. This is Snowflake ML, and this, until the explosion of popularity in AI, was the bread and butter stuff. Now, of course, the whole point of having a tree diagram is when there is so much information that we need more than one level, and that's why, as you might imagine, we've got to drill down into functionality within Snowflake ML. Here we have two broad choices: train and deploy models programmatically using Python or using SQL. These are the two choices, and the corresponding names are Snowpark ML, that's for the Python related stuff, and ML functions for everything that we can do from SQL. And at this point, it probably makes sense for us to refer to this diagram taken from the Snowflake docs. Everything here focuses on Snowflake ML, so we are not talking about Cortex at all right now. Like a classic three-tier web application, these diagrams tend to have three layers, and indeed that is true here as well. Let's go through the layers one by one. At the lowest level is the ML compute infrastructure. The custom models that we build and train could be either built on the container runtime or on the warehouse runtime. We will be working exclusively with the warehouse runtime in the demos up ahead. The container runtime is also newly released and specifically optimized for Snowflake workloads. Then one level up, we get to the kinds of APIs and building blocks available to us. This is where we see the choices corresponding to Snowpark for Python and ML functions for SQL. Right now, we've only displayed the components available under Snowpark, that is ML with Python APIs. The Snowpark ML modeling APIs allow us to carry out feature engineering and model training. These APIs allow us to work with scikit-learn, XGBoost, and LightGBM. Snowpark ML also has a pre-processing module that allows us to leverage Snowpark optimized warehouses. Then there is the feature store. This is also a newly launched feature which facilitates feature engineering and feature reuse. The word reuse is important here. And finally, there is the model registry, which helps with model management. So you can register your models, and models can have versions that are tracked. Also, the model registry will support models trained both within and outside Snowflake. All of this was the Snowpark ML Python stuff. And then there are the ML functions. These allow us to work with ML using SQL. This bit of functionality includes some pretty interesting models for anomaly detection, time series forecasting, something known as contribution explorer, and a good old classification function. That gets us to the top tier. This is how we interact with the system. There is Snowflake Studio. This is a newly released feature which is in preview that allows you to drag and drop and build simple ML models. These are currently only available for models in time series forecasting, anomaly detection, and classification. Snowflake notebooks can be thought of as Jupyter notebooks that are hosted within the Snowflake UI. It's very important to point out that Snowflake notebooks allow you to run both Python code and SQL queries seamlessly. So you can literally have alternating cells of Python and SQL. This is probably also a good place for us to talk about the machine learning lifecycle as visualized by Snowflake. Once again, a lot going on. Let's break it down. You see that originally all of the raw data originates from Snowflake tables, and then it is prepared and transformed using Snowpark ML modeling. The output of this transformation is a training dataset, and please note that the word dataset is actually a specific construct that is now available in Snowflake. Once again, this is a newly launched construct. So we take our training dataset and we use it to train a model. That model is written using Snowpark ML modeling APIs. That trained model is then registered with the Snowflake model registry, and it's also assigned a version. And at this point, the model can be used for inference, which in turn might require an inference dataset. The output of this model, of course, is the set of predictions. And one last bit about that inference dataset, because of the Snowflake feature store, the training dataset and the inference dataset can relatively easily be tracked, and there are excellent mechanisms for reuse across all of these different features. We've now discussed a very large number of features and technologies. Let's go ahead and learn how to use them.